Solving equations by extraction of roots. Let's first take a review of solving just general equations. To solve this particular equation, 2x equals 16, what it's saying is that 2 times the value of x equals 16. And we want to isolate the x variable. In order to do that, we need to do an equal but opposite operation. So the equal and opposite operation of multiplying x by 2 is dividing it by 2. Whatever we do to one side, we got to do to the other side of the equation. These two cancel out to 1, so we're left with a value of x equals 8. Now we get into using the extraction of roots. We'll take a similar example where we have x squared equals 16. What we're looking for again here is the single value of x. Here we have an x squared, and we're squaring the x value. What we need to do is take an equal but opposite operation of squaring a variable. Well, the equal and opposite operation of squaring a variable is simply taking the square root of that variable. Because what happens is whenever we take the square root of a square, they end up canceling one another out, similar to the 2 divided by the 2. But whatever I do to one side, I also have to do to the other side of the equation. So when these two cancel out, what I'm left with is the value of x equals the square root of 16, which comes out to being both a plus and a minus value of 4, meaning I have both the positive value of 4 and the negative value of 4, because the square root of 16 simply means that if I resubstitute this value of 4 into the equation, positive 4 squared does give me a value of 16, but also the negative value is also a true statement. Negative 4 times the negative 4 gives me back a positive 16. So whenever I extract the roots from the square root symbol, I have two possible. I got a positive value and a negative value. Okay, here's some more examples of solving equations by extractions of roots. Here I have x squared minus 5 equals 6. I'm always trying to isolate my variable, so what I need to do is try to get my variable, my x, all by itself on the left side and all my numbers on the other side. So to get rid of this minus 5, I need to add 5. Whatever I do to one side, I need to do the equal and opposite operation on the other side. So this cancels out. Obviously, I'm left with an x squared equals 11. And now, I haven't totally isolated my variable because I'm in the square form. I need to get a single value of an x. The way I do it is the equal and opposite operation of squaring something is to take the square root of it. Whatever I do to one side, I have to do to the other side. So what happens is these two values cancel out, so I'm left with an x equals the square root of 11, but now that I have two possible answers, I have the positive value and the negative value, so it ends up being plus or minus the square root of 11. So my answer in this case is x equals plus or minus the square root of 11. Now over here, I have 3x squared equals 27. Again, I'm trying to isolate my variable. Here it's basically saying 3 times the value of x squared equals 27. Well, just like I did in linear equations, I need to isolate my x value by itself. And I can pull these two apart. It's saying 3 times. So to do an equal but opposite operation of multiplication, I need to do is division. So I need to divide both sides by the value of 3. What happens is they cancel out to being a value 1. And I'm left with x squared equals 9. And to finish this bad boy out, it's just the same as we did over there. I'm now going to take the square root of both sides. So take the square root of the x squared and the square root over on the other side. And I'm left with a value of x equals, in this case, the square root of 9 is an actual whole number value, and it's plus or minus 3. If it ever ends up being a whole number, go ahead and finish out the whole number. In the previous example, I had a square plus or minus square root of 11. That's an ugly decimal, so we leave it into square root form. But if it comes out to being a perfect square or a whole number, we're going to go ahead and finish it out. Now I'm left with the quantity on the next equation. I have x, the quantity x minus 2 quantity squared equals 16. Again, I can't combine what's in parentheses because they're unlike terms. And I can't add the 2 out because I need to first do order operations. It tells me I need to square it. So what I need to do to get rid of it, the only way I can simplify this form is if I come through, because of the square sign, I need to take the square root right now in the beginning. So I need to take the square root of the entire quantity on the left side. Whatever I do on the left side, I got to do to the right side. And again, these values, this quantity cancels out with the squares, and I'm left with a value of x minus 2 equals plus or minus the value of 4, because that is the square root of 16. And to finish it on out now I can isolate my x variable by adding 2. Whatever I do to one side, I got to do to the other side, and that leaves me with x equals 2 plus or minus 4, which again is two possibilities. I have x equals 2 plus 4, or I can have x equals 2 minus 4. So my final answer in this case would be two possible answers. I get a value of 6, and I get a value of negative 2. Now on my last one, I have something very similar, so this time it's saying 4 times the quantity x minus 2, quantity squared equals 16. This 4 is outside over operations. Obviously my squaring exponents happen first, but this 4 is outside of it. So I can actually, I can't distribute it through because of the square, but I can divide it out. So I can divide this entire left side by 4, and whenever I do the one side, I got to do the other side. They cancel out, so I'm left with x minus 2 quantity squared equals the value of 4. And now, just like what I did over on the other side, I'm going to take my square root. Whenever I do one side, I got to do the other side. That leaves me with x minus 2 equals plus or minus the value of 2. And to finish it out, I need to add 2 to isolate my variable. Whenever I do one side, I do the other side. I'm left with x equals 2 plus or minus the value of 2. So in this case, I have a possibility of x equaling 2 plus 2, or x equals 2 minus 2. So my final answers are x equals 4 or x equals 0, and those are my two possible answers to that solution. Now I can always check by taking these values and subbing them back in, and I will get a true statement on both sides for all of these in each case.